Hello and welcome to a new video on the Crypto2 YouTube channel. In this video I want to have a look at codebooks. I want to show you how you can create your own codebook like that one that was used in the Zimmermann telegram. I structured this video into different parts. First of all, I want to speak about the history of Codebook Ciphers. Then I want to give you a brief introduction into the Zimmermann telegram. Then I want to show you how Codebook Ciphers work. And finally, I want to show you how you can create your own codebook cipher in Crypto2. Codebook ciphers are the enhancements of the so-called nomenclators. And nomenclators are ciphers that replace letters by other letters, symbols and/or digits, and they also use codes for specific words. So for instance, you replace the A with 01, 02, the B with 15, 16 and so on, so with digits. And then you have special words, for instance, like names or places, and these with nomenclators you replace with some other special codes. And an example for such a code would be that all codes start with, for instance, the digit 2, and then it follows a different number. For instance, the Pope is 213, the King is 256, and so on. And a codebook cipher then is a cipher that replaces all words of a plaintext with codes obtained from a codebook. So instead of replacing single letters, you have this codebook where you search for the code and then you replace each word with a code. And the brief history is that the nomenclators were used until the 19th century, and then in the 19th century and at the beginning of the 20th century, codebook ciphers were used and replaced the nomenclators. And codebook ciphers were then finally replaced by cipher machine ciphers, for instance, the Enigma machine. What is the Zimmermann telegram? The Zimmermann telegram was a secret diplomatic message sent from the German Foreign Office by Arthur Zimmermann in January 1970 to the embassy in Mexico. You can see Arthur Zimmermann on this side here. And it proposed a military alliance between Germany and Mexico against the United States in that case that the United States enter the war. And that was World War I at that time. The message was intercepted and decrypted by British Room 40, and then the decrypted message was posted to the United States. And the decryption was possible since Room 40 was in possession of the used codebook. And that particular used codebook, the so-called Signalbuch der Kaiserlichen Marine, was obtained by the grounded cruiser Magdeburg, and that ship was grounded near the coast of Russian Estonia. And so the Russians went onto that ship, they obtained the codebook, and then they sent a copy of that codebook to the British. And the British Room 40 then used this codebook to decrypt the Zimmermann telegram. And finally, due to the telegram, the United States declared war on Germany and entered World War I. You can see the Zimmermann telegram here on the right side. It was sent from Germany to Mexico, and here you see the different codes. And since the British had these codebooks, they could decrypt this and then send it to the United States, which finally led to the entrance of the United States to World War I. So how do codebook ciphers work? First of all, sender and receiver of course have to be in possession of the same codebook. And a codebook is a dictionary, and it has often hundreds of pages containing words and their respective codes. And to encrypt a message, the words are replaced by their corresponding codes. And of course, to decrypt then a message, the codes are replaced by their corresponding words. And often there was a codebook for encryption which was alphabetically ordered by the words, and there was another codebook for decryption which was ordered by the codes. And you will see later that there is a mistake, a common made mistake by the creators of codebooks, and I think they did this mistake because they didn't want to have two codebooks. Because what they did, they ordered the codebook alphabetically and then assigned the numbers also in an order, and that is really bad. You will see why this is really bad on the next slide. And if a word was not present in the codebook, its letters and syllables were substituted by codes also. So they had not only codes for words, they also had codes for single letters and syllables, so that you can send words that are not in the codebook. And sometimes the codes were then super encrypted. For instance, by shifting the code digits or applying a mathematical calculation on these. That should make it harder for a cryptanalyst to break the code. And here I have an example how a Codebook Cipher works. For instance, we have the message we attack at dawn and then something else. And first the we gets replaced by a number, then the attack gets replaced by a number, the at gets replaced, and the dawn gets replaced. And you find these numbers, of course, in the codebook. And then on the receiver side, the receiver looks up this number here, sees, oh, this is we, then this number is attack, this number is at, and this number is dawn. And now I have two common mistakes that were made in creation of codebooks in history. First, words were in alphabetical order. Thus, all codes for words beginning with letter A started with 1, codes of words beginning with letter B started with 2, etc. With the code words being, or the words being in alphabetical order, that's not the bad thing. The bad thing is then when you have the alphabetical ordered words, when you assign the numbers in an order. So you give the first word in the codebook the 1, the second the 2, and then in the end the last number is for the last word in the codebook. Then this makes it really easy to find words that are close together. And here with the example I make, you can see this. For instance, the attack and the at, they both start with 9. They are really close together, and that is because they start with the same letter. And to avoid this, you have to randomize that number that you assign to these words. Or you have to randomize the order of the numbers assigned to the words in the codebook. And then the second mistake in creation of codebooks was that codebooks were similar. Thus, having an old codebook helped a cryptanalyst in reconstructing the newly used codebook. And they really did this. So they updated the codebook and they took parts of other codebooks. The constructions were similar and it made it more easy to break these. And of course there was a problem when a codebook was obtained by the enemy but still used for encryption. Then of course the enemy could decrypt the messages as it was done with the Zimmermann telegram. So now let's do it in Crypto2. We have two tasks, and my first task is I want to create our own Codebook Cipher with Crypto2. And I do not only need Crypto2, I also use Excel and a text editor for this. Why, you will see in a minute. And then of course our second task is that I want to encrypt and decrypt text using our Codebook Cipher. I'm here now in Crypto2 and I want to show you how you can create your own Codebook Cipher. And instead of using a template, I will show you how you can create it completely by yourself. So first we need a new workspace. So we click here on New. And in fact, our monoalphabetic substitution component supports codebooks. And how this works, I will show you. So you first search for substitution. And we want one substitution for encryption. And I copy paste this because we want one substitution component for decryption. And I connect these here. And of course we need several text inputs. So we have here our first text input. This will be our plain text. And we connect the plain text, of course, with the first substitution. Then we need a second text input. And this here will be our words. These are the words that will be substituted with the Codebook Cipher. So we need one here and one here. And I don't want to forget it, so I do it now. I change the second component to decrypt. Then we need a second text input, or a third text input for the codes. So one to this and one to this. And this here is our codes. Line these a little, and then you can remove or move the line to this here and this line. Or we can just select everything, do this, and then the lines should be look nicer. And now we need two text outputs. So we have one text output here. This will be our cipher text. And then of course we have our decrypted plain text. Connect these. Decrypted plain text. And we connect this. So we have our plain text. It goes into the first substitution, gets substituted, so words will be replaced with codes. Then this ciphertext goes into the text output here. We will see our ciphertext here. And the ciphertext will go in the second substitution component and will be decrypted. And then we see our decrypted plaintext here. But now we have a problem, or not a problem. We still do not have any words or any codes here. And how can we get words into this text input? So, as I said, a codebook has a code for every word. So we need every word of a language. And of course we want to encrypt the English language or English words. And yeah, Crypto2 has English dictionaries. So we make a new temporary workspace and we search for dictionary. Put this dictionary here and then you can change here to English. And we need a text output. And then you need this here, the deprecated one. Actually, this is not deprecated. We should remove this since it's still needed. And when we execute this right now, we get here every word of the language. And now what can we do? Now that's actually not correct. We need it line by line because we want to have on the left side the word and on the right side we want to have the code. So I change this here to the second output. This is the, no, it's not wrong. Let me think. Append. Yes, that's right. So I changed it to the second output here, to the string array. And then I said, please append the text input. Maybe it's also not necessary, so we can remove this. Ah yeah, I remember. The text output supports the display of arrays. So if when you enter an array or input an array into the text output, you get it line by line. That's what I want. So we have here now all of our words. And as you can see also we have letters here. And this will help us if we have a word that's not part of the dictionary. So this is also encrypted. And now we just select everything with Ctrl A and then Ctrl C. And now it's time to go to Excel. So I paste all the words into Excel. And now what we want to have is, of course, we want to have digits here. So our first code starts with 10000, so 10000. So we have 5-digit codes. And now the next word should get the next code. So what do? We say this equals to this cell plus 1. I'm really sorry at this point that this here is in German. I tried to change it to English, but it didn't work on this computer. So I'm sorry for that. But it nevertheless should work also with an English version as shown here. So you do the same here. And if you don't want to repeat this several times, of course, you can just drag it down to the end. So just mark everything to the end of our codebook and Ctrl V. So we have now code word with code assignment for every word we have here. So our codes go from 10000 to 51237. Yeah. And now we have a problem because we did the same error that the code book makers in history make, because we have now alphabetical order and the numbers also ordered. And here's a really nice trick. You can just say here, in English it's random, in German it's Zufallszahl. So Zufallszahl. And in English it should be something like rand, I think. So this gives you a random number between 0 and 1. And what you can do is now you can fill these also in the table here. And now we have a random number for every entry in our codebook. So why do I do this? I now mark again everything here. And Ctrl C. And then I paste it again, and I say I only want to paste values. That's very important. So now we don't have the equations here, we have the values. And now I delete this. And what I can do now, I can just mark every column here, and then data, and in English it's sort, and then I sort by the third column, the column C. And there's still a mistake. You need to copy this here, also with values. Sorry, I forgot this. Now we have also values here, and then we can Control C, Control V it here, or Control X and Control V. Now we have here no equation, we have here the random numbers, and now we can sort. So we say data, sort after column C. And what you can see, it just shuffled our code book. And it did it by sorting the random numbers we generated. So it doesn't start here with an A, it starts with a B, and then we have dissolve, paperback, so it's shuffled. And you can remove this here. Yeah, and now we have to put this into our codebook or into Crypto2. And how do we do this? So first you mark the first column. And now I use a text editor that's called Cite. And paste this into the text editor. And then I go to the top here. And I say search replace. So what do I want to replace? I want to replace \r, \n. These are the line breaks. And I say I want to transform / expressions. And I want to transform it to this bracket and this bracket. Replace all. This takes some time because we have a really huge codebook. And it did it. Then we go to the beginning and we make a bracket at the beginning. And then we go to the end and remove the additional bracket we don't need. Then we mark everything, Control C, and we go to Crypto2. We don't need this anymore, so we can close it. And we go to our words, Control V. And now we have all the words here in brackets. And why do we want to have these in brackets? This is because the substitution component uses everything that is in these brackets here as a single word. And if you don't do this, it assumes this is a single letter, it has to substitute, this is a single letter. But if you put this into brackets, it recognizes this as a single item. Now we do the same with the numbers. So we go back to Excel, we copy our numbers, we go into Cite, make a new, and then we say, we go to the start and then replace all. And this also will take some time. Then again we go to the beginning, add the missing bracket here and remove the additional bracket at the end. And then we select everything with Control A, Control C, Control A, Control C, and go into Crypt tool and Control V. Now we have our codes for our words. Now we have to change some settings. So we will say this input separator symbol is a space because our words are separated by by spaces, and the output separator is also a space. And with this here we will do the same, space and space. And now I want to change a small thing. I want to move this substitution down, and I want to add string operations component, because all our words are lowercase, and if we write a word that has an uppercase letter, it won't work. So what we will do here is we will change everything to lowercase. And we connect these here. And now we can play. So let's test it. So we press an H here. I want to write hello world. So H is replaced by this. Then E, L. And now you see a word that doesn't work. So it just is forwarded. It's not encrypted. So you always see which words are not part of the codebook. And then you can change these to parts that are in the codebook, and then in the end everything should be encrypted. So we have here hello world, and then a comma, and it doesn't work, so we make space. This is a test of the Codebook Cipher. And as we are typing, you see that all the parts are encrypted again. Now let's assume we want to encrypt a name. For instance, my name is, and as you can see, the my is not part of the codebook, so we just make here a space, and the M also is not in the codebook, so I think the problem here is we need a space. Yeah, we need a space here. Same as with cipher. So we have C-I-P-H-E-R and space. And then Niels is not in the codebook, so N-I-L-S. Yeah, and this is how it works. And as you can see, the decryption also works. And this was everything that I wanted to show you with Codebook Ciphers. You can now create your own codebook with Crypto2. And when you want to exchange messages, for instance, with a friend, you have to create this workspace here. And since our codes are ordered in a random manner, this is a really strong code. And what you can do is you can give the same workspace to your friend, and then you two can use this here for encryption and for decryption. Yeah, thank you very much for watching. I hope you liked this video. If yes, please give a thumbs up. If no, you know what to do, give a thumbs down, and see you in the next video.